Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about dynamic arrays which are multidimensional in nature. So consider the example we have discussed previously. This is a two-dimensional array. This is how we initialize it when we want to really keep things firm and fixed. Now the same thing that has been written here could have been written in this way. Now the whole purpose of writing it this way is to really see how does the computer sees it. I mean, we look at this as a two-dimensional array, but how does the computer see it? Well, for the computer, our matrix here is nothing more than just an array with elements stacked on top of one another. So we see here are 6 elements, 1, 2, 3, 4, 5, 6, where 1 and then 2 and then 5 and then 6, 8 and 9 are stacked on top of one another, and we see here the addresses increment by 4 bytes because one integer takes 4 bytes in the memory. So from 1 we jump to 5, from 5 we jump to 9, from 9 we jump to 13, and in hexadecimal it's represented as D. Now we're just going to see this array in addresses not by hexadecimal, by decimal, because they're easy to see, right? So over here you see that I've renumbered them to decimal values because they're easy to see and see how things go by. So let's consider some basic principles, right? Here you see a 3 by 3 matrix. There are 3 rows and 3 columns, and the address of the first location, which is 0 row and 0th column, right? Remember, arrays start from index 0, 0, is known. So the address of the first location is known. So we have 3 constants: number of rows, number of columns, and the location of the first element. Now all we need really is a formula that can find a relationship between our indexes I and j and the address which they occupy in the memory, because as far as the memory is concerned, these elements are just stacked on top of one another. So all we need is really a formula that translates this I and j into the actual address, and we are done. Now consider our array again. Let's look at the first row. Well, if the address of the first location is 1, then the address of the second one is 5, the address of the third one is 9. Again we see, because one integer is 4 bytes, we see 1 plus 4 is 5, 5 plus 4 is 9. And then what about 5? Actually 9 plus 4 is 13. And we see that the address of this guy is supposed to be location 13. And because 7 is 1, 2 integers away, so if this is the base address, this is 2 integer offset. In other words, it's 8 bytes away, so we see 13 plus 8 is 21. And then for the last 3, it's 25, 29 and 33. We again see here an increment of 4. But what about a formula? Let's say this is my formula. So P is, again, remember there are 3 things that I know. One is the base address, which is 0, 1. C, which is the size of the number of columns, total number of columns, and R. So if what this particular formula means is that for any given index I and j, the address can be found by the base plus the offset, where the offset is the number of rows I times the number of columns and added with the number of column j. So for 0, 0, obviously it's 0 times 3 because there were 3 columns, right? This is 1, 2, 3 columns, so this is 3, and j is 0, so obviously 0, 1 is the base address, plus 0 is just 0, 1, so that's the address. For the second element, right, let's look at the formula again. So P, which was the base address, was 0, 1, I is still 0, but j is 1. So this becomes 0 times 3 plus 1, this becomes 1, so 1 integer away is equivalent to 4 bytes away. So 1 plus 4 is 0, 5, and that's what we see as the address here. We can see that again when the base address is again 0 1. I in this case is, this is the 0th row and this is 0 1 second column. So the index is 0 and 2. So 0th row and second column. And we see again it's 0 is multiplied by 3, that's 0, and 2 comes as is. So 2 in integer type is equivalent to 8 in byte types. So this is equivalent to 0 1 plus 8, which becomes 0 9, and we see we reach this address. So the interesting actually comes here. So again, P is still pointing to this guy, which is 0 1, and this is the first row and 0th column, and we see that here, first row and 0th column. So we put that in the formula, and 1 times 3 becomes 3, and this becomes 0. So 3 in integer types is equivalent to 3 times 4 in bytes. So that's 0 1 plus 12, and we end up with 13. This is a typo, this should have been 1 3, right? We end up at 13. And this is just how we see this is the first row and the second column. Now we can reach here directly using this base address of 0 1 and this formula. So 0 1 plus 1 times 3, because there are 3 columns, plus 2, that's 3 plus 2 is 5, and 5 times 4, because every integer occupies 4 bytes, it's 20. So 1 plus 20 is 21, right? And as the last example, let's do this again. So this is just to explain to you that this is the formula that we are really going for. So P is again this address 0 1. This is the 0 1 2 second row and the 0th column, and we see that to be occupied by location 2 and 0. So 2 times 3 plus 0 is 6, 6 4s are 24, and 1 plus 24 is 25. In other words, this particular matrix, when it's reflected onto this array, I mean this location in the memory, we can know the exact location in the memory by using this formula, where this is our base and this is our offset. Obviously, whatever the offset comes out, if it's an integer, you multiply by 4, and if it's a double, you multiply it by the number of bytes a double variable takes. So effectively, the whole process becomes very easy. You have two variables. R represents number of rows, C number of columns. So you take in the number of rows needed by the user and the number of columns, and lo and behold, you just write new integer R times C, right? Because for 3 rows and 3 columns, you have 9 memory locations that you need, and so it's just R times C. And then you can access individual locations by using the formula, right? P plus I times C plus J, that's the formula we actually came up with. And the contents of this particular address are updated to K, right? For printing it, we use the same function we developed in lecture number 14. We are giving it R, the number of rows, C, the number of columns, and the address of the 0th location. Now I'm not going to run this in cpp.shell. I'm actually going to run this in the, this is our code. This is the function we developed in lecture 4. And this is the place where we declare a multi-dimensional array. Just R times C. It's really as simple as that, right? Here we are asking the user to put in values. We update the contents of this particular address to whatever value of K we receive, and then we print it. Before we leave, we always delete the locations in the memory that have been reserved, because we do not want any dangling pointers. Okay, so this is lecture 16.cpp. That's the code which is present for this particular lecture. So I'm going to do is I'm going to compile this. So G++, because this is C++, lecture 16.cpp, and the output I just want to remain as lecture 16. When I press enter, you will see an executable code that pops out, right? That's our executable code. The icon is also different. And then I just run this lecture 16. It asks me how many rows. I say, let's say 4 rows. How many columns? 2 columns. And then I just start entering the numbers. And let's see how they come out. That's our matrix, right? So using the formula we discussed, you are able to have any multi-dimensional array developed by the user. It could be 3 by 2, it could be 10 by 10, it could be 1000 by 3000, whatever it is. But just be sure that there's enough space in the memory. You can do that by putting in new no throw integer. So no throw actually helps you, right? You can put this, so if there's enough space, it'll actually allocate it. Okay, so with this you can actually initialize and use as dynamic multidimensional arrays as possible. Thank you very much for listening to this lecture. If you like this video, subscribe and hit the bell icon. And if you have any questions, just put them in the comments below and I will answer them, because a lot of students have similar questions in mind, and by putting them in the comments below, it gives me the opportunity to answer everyone. Up until next time, thank you very much. Bye bye.